Alright, so you guys are probably familiar with the rectangular coordinate where we have a point, let's say some arbitrary point P, x, y, where x represent for the horizontal value and y represent for the vertical value. Well, okay, so now we have some point in a rectangular. That's what we call it, a rectangular form or rectangular coordinate. Well, so is there any other way that we can represent a point using some other coordinate? Well, today we're going to introduce a new coordinate, which is the polar coordinate, which is not that new. It was invented a couple hundred years ago, but it's quite new. It's quite different from the rectangular coordinate. With the polar coordinate, we don't locate a point according to its horizontal value and its vertical value. We determine a point and locate where it is based on how far it is away from the origin and what angle would be elevated from the horizontal axis. Okay, so instead of have p x y, we may have p r theta. Right. So that is just a new way to operate a point, a new way to locate a point. So we may say OP is some r, or you can think of it as just a vector. But here we denote it to be a scalar. How far is it away from an origin, which is r, and we denote theta, which is the angle. How is it elevated? How much of an angle will be elevated from the horizontal axis? All right. So here we have it. But the important thing about operation is that you can, when you come up with a new denotation or a new notation, you got to be able to transfer it back to the original operator or transfer it back to the original set. So here we have r and theta. How do we transfer back into the rectangular coordinate, which is x and y? Well, here we have r. We could think of this this triangle right here, which is a right triangle, O, P, O, and maybe some point on the x-axis, some value a, but we go ahead and denote it to be point A, big A. Okay, so we have the rectangular OPA right. It's a right triangle at 8. So OP becomes the hypotenuse, the longest side, and OA become the adjacent, and PA become the opposite with respect to theta here. Okay, so PA will be the vertical value. Therefore, how do we transfer back to which is, we can call this y. So therefore, y would equal to r times sine theta, and correspondingly x would be r times cosine theta. Right. And you know, according to the Pythagorean theorem, it works because x squared plus y squared equal to r squared. Right? When you square this up, this becomes r squared times cosine squared theta. This you square this up, this becomes r squared times sine squared theta. R squared times sine theta plus cosine theta squared. Sine squared plus, we have an identity, right? Plus cosine squared theta become a 1. So that's only give you r squared. Alright. So we know that we can transfer back and forth from coordinates, from rectangular to polar. Alright. So what was the great thing about this? Okay, we can transfer it to a new coordinate, but what can we extract out of this new notation? Well, let's look at some curve and see what we can do from it. Alright.